Friends, let's solve this problem. Find the nth term of the quadratic sequence. A quadratic sequence is a sequence of the form n squared. Maybe plus or minus b. Okay? Once it looks this way, it's a quadratic sequence. Now, this is the nth term anyway. But there is a way, what we try to establish is that the way we find out whether the n squared is embedded in the sequence. Now, if I have the smallest form, the simplest form of it is where a is 1. So u subscript n equals n squared. So this is our sequence. The problem we're trying to solve. And n squared is, if n is 1, you have 1. If n is 2, is 2 squared 4, 3 squared 9, 4 squared 16, and on and on. Okay? So there's a way we find out whether this, it could be a multiple of powers. In other words, you could have, once what is not here is not 1. That is, in other words, if a non-monic function, that is, if a is not 1, is a, we call it multiple of powers. So it could be 2, could be anything. So that's the way we find out. Now, the way to go about it is just we check this is 3, and this is 7, 13, and 21. If I want to move from 7 to 3 to 7, I will add 4. To move from 7 to 13, the difference is 6. From 13 to 21, the difference is 8. Call it first difference. Now, second difference is from 4 to 6 is plus 2. You add 2 to 4 to get 6. 6 to 8 is plus 2. See, it's the same. Now, once you have to know that un is n squared, that is, this coefficient is 1. Okay? Now, what it means is that this is n squared, but check the difference between the sequence and n squared. The standard sequence is this. Watch. You see, for me to get to the sequence whose n term we are to determine, I have to add 2 to 1. That is 2 plus 1, giving me 3. For me to get to 7, I have to add 3 here. 3 plus 4 is 7. For me to get to 13, I will have to add 4 here. I will have to add 5 here. So what we try to find out is what this is, because this plus this gives us the sequence. That is, whatever we have here plus the quadratic term gives us this. So we try to find out. Now, look at this. It looks like an AP, arithmetic progression to me, because the difference between two successive terms is 1. 3 minus 2 is 1. 4 minus 3 is 1. 5 minus 4 is 1. So it will obey this formula, a plus n minus 1 all d. Okay? Where a is the first term, in this case is 2, n is the term we're looking for, d is the common difference, which is 3 minus 2, which is 1. So we can have un equals a, which is 2 plus n minus 1, difference is 1. Evaluate this, we have 2 minus 1 plus n, that is n plus 1. What it means, this is n plus 1. Check, if n is 1, 1 plus 1 is 2. If n is 2, with the second time, 2 plus 1 is 3. If n is 3, 3 plus 1 is 4, so it's consistent. Therefore, 2 to get to 3, which is the sequence, 2 plus 1 is 3. So if this becomes our un, to get to un, we add this plus this plus. So un becomes n squared plus n plus 1. See that? We could just test whether the veracity, we can tell the veracity of the n term. So let's check the first one. 1 squared plus 1 plus 1. That's 3. It's okay. Let's check the last one, which is 1, 2, 3, 4. 1 and it's 4. 4 squared plus 4 plus 1. 16 plus 4, 20, 21. So it's correct. So the next time, maybe let's and 5. 5 squared plus 5 plus 1. That is 31. So the next term here will be 31. We can check the third term. 1, 2, 3. U3. 3 squared plus 3 plus 1. 9 plus is 13. So it's correct. Thank you very much.